Alright, in section 10.1, it's also parts of 6.4. They talk about square roots and cube roots. So first you should probably understand what squares are. Squares are just numbers that multiply them times themselves. So 1 squared is 1, 2 squared is 4, 3 squared is 9, and so on. All the way up to 12 squared is 144. And for the cubes, 1 cubed means 1 times 1 times 1, 2 times 2 times 2, and so on. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, and so on. So, when they ask you what the square root of something is, they're asking you what number times itself equals this guy underneath here. Well, it's 1. What number times itself equals this number here? Well, it's 2. What number times itself equals 9? Well, that's 3. What number times itself equals 16? That's 4, and so on. So if you know what the square is of a number, you can know what the square root is. And the same thing here for the square root. The square root of the cube root of 8 is 2 because 2 times 2 times 2 is 8. The cube root of 64 is 4 because 4 times 4 times 4 is 64. Cube root of 125 is 5 because 5 times 5 times 5 is 125. Now how do you do the square root on your calculator? Well, you hit second x squared. If you hit the second and then the x squared, it gives you the square root symbol. And now you just type in 25, enter, and it gives you 5. All right. Now how do you do cube root? That's a little more difficult. You have to hit what root you want first. Hit the root, mean third root. Now you got to hit math 5. Okay, just math 5. And now notice it says cube root there. It's hard to see there, but there's a cube root there, a little 3 there. And now type in 64, and you get 4. So if you want to do the cube root of 216, you hit 3, meaning the third root. Then you hit math 5. And then type in 216. Alright, for square root, it's easier. Just hit second x squared. And then you type in 36, and the square root of 36 is just 6. Alright? So, when you're asked what's the square root of 25, they're not really asking just the square root of 25. They're asking you what's the principal square root of 25. And sometimes they might ask you what's the negative principal square root of 25, but whatever. For now, let's just think of the square root of 25 is just 5, because 5 times 5 is 25. Square root of 0.49 is 0.7, because 0.7 times 0.7 is 0.49. Square root of 4 ninths is 2 thirds, because 2 thirds times 2 thirds is 4 ninths. And the square root of c squared is c, because c times c is c squared. Now you can approximate something that's not a perfect square, like square root of 17, on your calculator. Give you out as many decimal places as you want. And you round it, in this case, to the third place, and so that 1 does not change to 3, and it stays the way it is. There's a formula for calculating the distance in miles that one can see based on their approximation x elevation in feet. So if a person is 6 feet tall, they're 6 feet off the ground, and so that's the number you plug in there, and that's how many miles they can see. So a 6 foot tall person can see 2.988 miles across the land to the horizon. And what if a person is on a 8,000 foot mountain top? Well, that's 8,006, because they're 6 feet tall plus the 8,000 feet. And you plug all that in there, and you take the square root of it and multiply by 1.22, and you get 109 miles. So you can see quite far if you're at 8,000 feet. Alright, cube roots. The cube root of 8 is 2. I already told you that. The cube root of minus 27 is 3, negative 3, because negative 3 times negative 3 times negative 3 is negative 27. Cube root of 1 over 64 is 1 over 4, because 1 over 4 times 1 over 4 times 1 over 4 is 1 over 64. Cube root of d to the 6 is d to the second. And the cube root of 16, that one's not a nice one. You got to do that one and round it. Alright. So, if you take the square root of 64, you get 8. Negative square root of 64, you get negative 8, because the square root of 64 is 8, and you got the negative out front. But if they ask you what's the square root of negative 64, that's undefined. There's no real solution, because you cannot take the square root of a negative number. Now, cube root, you can take the cube root of a negative number. Cube root of 64 is 4. The negative cube root of 64 is negative 4, because this part is 4, and you still have the negative out front. And the cube root of negative 64, well, that's also negative 4, because negative 4 times negative 4 times negative 4 is negative 64. Now what if they ask you to do another root other than second or third? You can do fourth, fifth, fourth root. Again, you just have to hit the root first. So if you want to do the fourth root of 16, you hit 4, and then math 5, and then type in the number you want to take the root of, and you get 2. Fifth root, you type 5, and then math 5. It's always math 5 after you type in whatever root you want, and then negative 32, and it gives you negative 2. And then what about the fourth root of negative 81? So you got to hit 4, and then math 5, and then negative 81, okay? And it tells you non-real answer, meaning you're not going to get a real solution. There's no real solution to this. Don't just say no solution, say no real solution. All right? And then negative fourth root, so you got to hit the 4 and then the math 5 to do the fourth root. Oops, we got to get out of that first, sorry. So negative 4, math 5, and type in 81. And you get you type in 81. Maybe I typed in the wrong root. Oh, I typed in negative 4. Alright. So you have to do, I think, negative parentheses and then type in 4 math 5 81. Arrow to the right and then have close parentheses, and then that should give you the negative 3. Yeah. So you have to put the radical. This is called the radical. You got to put the radical in parentheses. And once you've typed in the 1 after the 81, you have to arrow to the right to get out from underneath this radical. Because otherwise you'll put the parentheses underneath this radical, and you don't want that. You want it after the radical, not underneath. Yeah, that's a tricky one to actually do on your calculator. Alright, now if you take the square root of something squared, you get technically the absolute value. So the square root of this guy squared, or the square root of x squared, is just the absolute value of x. And what does that mean? It means whatever value you have for x, if it's negative, you take away the negative sign. If it's 0, it stays 0. If it's positive, it stays positive. So absolute value only changes negatives to positives. It doesn't do anything to a 0 or a positive. So the square root of negative 3 squared is the absolute value of negative 3, which is 3. And the square root of x plus 1 squared is the absolute value of x plus 1, and we don't know what that is yet unless they tell us what x is. We can't know to get rid of the negative or not. We have to figure out what that is first. And then part C, if you were to factor that, the square root of z squared minus 4z plus 4 is the same thing as the square root of z minus 2 squared. And so the square root of something squared is the absolute value. And again, you can't simplify that because you don't know what z is. Alright, so this one says f of x equals this. What's f of 1 and f of negative 2? So you plug in a 1 in there and you simplify it down. And you plug in a negative 2 in there and you simplify it down. And this one you don't get a real answer. Then here, 4 minus x squared, where you plug in either a 1 or a negative 2. And you got to be careful with your parentheses when you plug these in. You get square root of 3, and here you get 4 minus a negative 2 squared is positive 4, but 4 minus 4 is 0, and square root of 0 is just 0. That one's a tricky one. Alright, so the other idea that they talk about in here, other than square roots and cube roots, is Pythagorean theorem. Pythagoras was a Greek gentleman over 3,000 years ago. Supposedly he was in Persia, visiting an Arab friend of his, and he saw a detailed mosaic tile on the floor. And what he saw was that he had a triangle, part of the tile floor, and on one side of the triangle there were three sides, and this side that had 4, and this side had 5. So this was 3, 4, and 5. And you notice that this was 3 times 3, or 9. This is 4 times 4, or 16. This is 5 times 5, or 25. And he happened to notice that 9 plus 16 adds up to 25, and he asked himself, wow, I wonder if that's always true. And it turns out it is true. And that's what the Pythagorean theorem is, which is the two shorter sides squared. You square each of the two shorter sides, A and b, you square them, and you equal their sum of those two numbers will equal the square of the longest side. And the longest side, the shorter two sides are just called legs, leg A and leg B, but the longest side has a very specific name. It's called the hypotenuse. Hypotenuse is always the longest side of a right triangle. It has to be a right triangle. It has to have a 90-degree angle to it there. And the angle, the side opposite that right angle is called the hypotenuse. And now the formula, a squared plus b squared equals c squared, is always true for all right triangles. And so they ask you, let a equal 6 or let a equal 8 and b equal 6. What is c, the longest side? So the one side squared plus the other side squared equals the longest side squared. Well, you know these two sides squared is going to equal this side squared, and that's 64, that's 36, which adds up to 100. And if c squared equals 100, you can take the square root of both sides and you get c equals 10. And so you can find the longest side if you know the two shorter sides. Alright, and now this one is 17, 10, and we don't know what the longest side is, but we know what these two sides are. And we do the same math here. We square this, and add them together, and then we take the square root of both sides, and we get 19.7, roughly 20. Then here they give you the longest side and one of the shorter sides. They don't give you the other side, so they give you A and C, but they don't give you B here. So once you've figured out your A and your C squareds are, and you subtract the 25, you get B squared equals 24. Take the square root, and you get square root of 24, or 4.9. And then this one talks about dimensions of a park. If the park is 300 feet by 300 feet, and they want to know what the diagonal length is, well, that means 300 squared plus 300 squared equals c squared. And you square those two and add them together, and you get 180,000. Take the square root, and you get around roughly 424 for the c, for the diagonal. And so here's the similar questions here in your homework assignment. So the first one, square root of 4 is just 2. Square root of 144 is just 12. Cube root of 64 is 4. Cube root of negative 64 is negative 4. Fourth root of 625 is 5. Fourth root of negative 16. You can't take the fourth root of a negative number. You cannot take the even root of a negative. Does not exist. No real solution. Now the square root of 16 over 24 is the square root of 16 over the square root of 24, and each one is just 4 and 8, and so you get 4 over 8 is 1/2. Square root of 15, they want you to approximate that, and you can get your number there, and same thing here with the square root of 26. This one's the square root of each one separately, and each one gives you 7 and 12, respectively. And then here they're throwing some Pythagorean problems at you. They give you the two shorter sides and ask you to figure out the third side. We've already done problems like that already. And here they give you one of the two shorter sides, and they give you the hypotenuse, the longest side, and ask you to figure out what this side is. So you have to subtract 100 and then take the square root. And you either get 2 square root of 11 or 6.633, depending on which one you want to use as your answer. And now this one, they give you the two shorter sides and ask you to find the longest side. And it's just a matter of doing the Pythagorean theorem. Nothing new there. And 51, they give you a city block that's 100 yards on each side, and they ask you to find the length of the diagonal. So each of the sides is 100, and the longest side is the diagonal. And you square everything out, and you find the diagonal is 141, approximately. Now here they give you a tree. You're 20 feet away from the tree, and you know that it's 32 feet to the top of the tree, and they ask you, what's this third side? B. So you don't know what B is, but you know A is 20, and you know hypotenuse is 32. So 20 squared plus A squared equals C 32 squared. Subtract 400, take the square root, and you see it's approximately 25. Alright, and so all of these guys I think are the same as what you're going to see on your homework. Let me see if there's any of these that are a little bit different. No, they're all the same as what you saw on your homework assignment. Nothing unusual there.